This is the world's largest supercomputer El Capitan, with over 1 million CPU cores and 10 million GPU cores at its disposal. Some might call it blazingly fast, but Google just unveiled a new quantum chip named Willow that can fit in the palm of your hand and solve certain problems septillion of times faster than this future dinosaur. To put that in perspective, a problem that takes Willow 5 minutes to compute would take El Capitan this many years. That's more years than the age of the universe, even if you had an El Capitan supercomputer for every grain of sand on Earth powered by a Dyson sphere around the sun. It would still be many times slower than Willow. But the Americans aren't the only ones making breakthroughs in the quantum computing field. Just days ago, China introduced a record-breaking 504-qubit superconducting chip. After seeing this big number, people on the internet started freaking out because a computer this powerful could break unbreakable encryption algorithms and steal all those hawk TWA tokens that you just yellowed your life savings into. But that's ignorant. By the end of this video, you'll understand how quantum computing actually works and why it still totally sucks as of today. It is December 10, 2024, and you're watching the Code Report. On one hand, quantum computing could lead us to a utopia that unlocks fusion energy, artificial superintelligence, and immortality with nano-robot doctors, but it also poses an existential threat to humanity. Computing at this speed means that unbreakable encryption algorithms are suddenly rendered worthless. Any hacker with a quantum computer could instantly brute force your RSA encrypted communications on the internet, or worse yet, crack your wallet seed phrase and steal all your daddy tokens and NFTs. But despite Google and China making some big breakthroughs, this technology is still nowhere near being useful. To understand why, you first need to understand how quantum computing works. The classical computers, like the one you're using right now, rely on bits, binary zeros and ones, to process information. Each bit represents a single state, like a light switch, and you can combine them together to do complex things like stream this video around the world. Quantum computers also use ones and zeros, but put them in something called a quantum bit or qubit. The key difference, though, is that they can represent the quantum superposition of multiple ones and zeros at the same time. Like, you can imagine a qubit as a box with a cat inside, and when you open it, there's a certain probability that the cat will be dead or alive, but you don't know until you open it. Mathematically, the equation looks like this, where A and B are probabilities called amplitudes that the qubit will collapse to a 0 or 1 when measured, and that means one qubit can represent a ton of information and compute in parallel. What's really weird, though, is that these qubits can become entangled, where the state of one qubit is directly related to the state of another, even though they're physically very far apart, and that weird behavior can be used to coordinate computations using quantum gates. They can do things like flip a qubit and create entanglement to provide a similar purpose to logic gates and classical computers, but do so by leveraging quantum mechanics. Magic sounds awesome, but the big problem is that qubits are extremely delicate and they consistently produce errors, with some qubits having higher error rates than others, and that means they constantly need to deal with error correction to keep the thing stable. Not to mention, these chips need to be kept at temperatures near absolute zero to even work, so don't expect an Apple quantum phone anytime soon. Now, one thing that's special about Google's Willow chip is that it's able to find qubits with high error rates and reconfigure them on the fly, therefore reducing the overall error rate. And what's especially weird is that the error-corrected qubits get exponentially better as they get bigger, and Willow is the first chip to ever do that. Another big problem with qubits is that they need to be aroused into a state of superposition and can only maintain that state for about 20 microc in the past, but on Willow they've increased it by 5 times up to a 100 microc. That's still not a lot of time, but Google's next big milestone is to build a long-lived logical qubit. Willow only has 105 qubits, but can still perform certain calculations like finding the prime factors in a large number much faster than classical computers. Algorithms like Shor's have been around since the 90s to do this, but we've never had the quantum hardware to actually run them. In theory, when quantum computers get to around 2000 qubits, they should be able to break widely used encryption systems like RSA using simple brute force techniques that would take classical computers millions or billions of years currently. And what's scary is that the Chinese just released their own quantum chip with 504 qubits. That's impressive, but the real thing to watch here is the error rate. Once the error rate gets low enough, we'll hit that inflection point that allows quantum computers to scale up exponentially and change the world in unimaginably good and bad ways, but this timeline has been all messed up since that fateful day on May 28, 2016, and the best way to keep up as a developer is by hanging out with other developers on daily. Div, the sponsor of today's video. It's a completely free social platform that curates all the best of developer content on the internet and helps you connect with other like-minded people instead of scouring the bowels of Reddit for an update on your favorite JavaScript framework. You can rely on Daily Dodev to pull all the best content from over 1,000 top sources to get all the best news, tutorials and videos in one place, and when you install their highly rated browser extension, is staying up to date becomes an easy daily habit. Join over 1 million other developers on daily Div by using my invite link on the screen. This has been the Code Report. Thanks for watching, and I will see you in the next one.